cool. No curse words. We're live. Okay, so Vx initial, so we have this ball, or whatever it is, leaving the ground and coming back down. It has an initial velocity of 32. Vx initial, is this the adjacent or the opposite side of the triangle? Adjacent. So we go over to our cheater equations here. Adjacent is hypotenuse cosine theta. So let's solve for it. Vx initial equals, what are we going to write? Hypotenuse cosine theta. What are the numbers though? Very good. 32 cosine 50. So we can type that, plug it in the calculator. So 32 cosine 50. I'm getting 20.6. Cool, thank you. Meters per second. And that is positive because it's moving right. Now the nice thing is, if you're solving for two sides on the same triangle and you have the hypotenuse, the other side, the opposite side, is just going to be the same thing, 32, 50 degrees, but it'll have sine. So 32 sine 50. And if you were to use that equation up there at the top right corner here, it's the same thing. Opposite equals hypotenuse sine theta. Well, 32 is your hypotenuse, we're using sine, and then 50 is still the angle. So a fast way to do this in your calculator, press the up button, or if you're using a graphing calculator, click second entry, and then you just arrow over and change it to sine. 24.5? Yes. All right, thank you. And that's positive because it's moving up. All right, we've got two things already. So we should probably label them. This is Vx initial. Got it. This is Vy initial. We got it. And so over here, let's start with Vy final. So Vy final is an arrow that points up or an arrow that points down. So in this case, when it returns back to the ground, is it moving down or up? Down. It's moving down and to the right. So we have a similar looking triangle. We have Vx final and we have Vy final. So to find Vy final, we're using those equations that we put on the board for the horizontal projectiles. Same thing as before. But we need one more y variable. So do you know, like the other things we could use are, I mean, we have Vy initial, that's 24.5. To find Vy final, we need to use two other things. So we either need, I'm going to just do some scratch over here. Time, or AY, or delta Y. If you know one of those, shout them out. Yeah, we have AY. It's negative 9.8. We also have delta Y too. Anyone know what it is? 0. Delta Y is 0 because delta Y is our change in Y position. So we start on the ground, we end on the ground. Our change in Y position is 0 because we start and end at the same height. So we have those two values as well. The best equation, in my opinion, would be, well, we tend to like, oh, we can't use that equation. Let's go with this one. Vy final squared equals Vy initial squared plus 2 AY delta Y. So we'll use this to get Vy final. So Vy final squared is 24.5 squared plus 2, negative 9.8, 0. Zero times anything is 0. So does anyone see what's about to happen? Nah. Yeah, the 2 cancel. So 0 times 9.8 times 2 is just 0. So we'll have whatever 24.5 squared is. I just typed in. It's going to be. Yeah. So we're squaring this number. You know, maybe you don't need to write this down if you understand what Megan's saying there. She's right. So we just squared 24.5, and then we're going to square root it again. And so we're going to get the same thing. So we'll get 24.5, but when it hits the ground, is it moving up or down? Oh no, you guys already answered that. You guys said it's moving down, so it's negative. So this follows that same rule that we had before. If something leaves the ground with a y velocity, it returns to the ground with an equal and opposite velocity of the same number. So it left the ground with a y velocity of 24.5. It's going to return to the ground with a y velocity that's equal and opposite. It doesn't matter that we're moving sideways. It's still going to have that same rule. So Vy initial and Vy final are equal and opposite whenever delta y is 0. And that's pretty cool. Like if you think about the math, if delta y is 0, it cancels this stuff out. So you have Vy final equals, you just have these two equal to each other. Pretty cool. So we could label that on our picture if we wanted to. But let's get to the Vx final. Anybody know? So Vx final is a little bit of a trick. We could go ahead and figure it out, or I don't know that we could actually. Anybody know what Vx final is? I kind of added this in as a trick. I think I heard someone say 32. It's not 32. Very good. 20.6. For a projectile, Vx doesn't change. So I kind of added that as a trick. This is 20.6. But the point of that is a lot of things. I'm getting too ahead of myself there. But basically, this is why we don't have Vx final. On most of the equations, we just write it as Vx. I'll probably never write that down again for these types of problems. Vx initial and Vx final, we just write them as Vx because they're the same number. But the cool thing here is that our triangles are similar. So that term in math, similar, it means that they're, well actually, what's the word for triangles that are exactly the same? Is that congruent? Or I guess you could just say exactly the same. But yeah, congruent. So these are congruent triangles. This one is 20.6. This one is 24.5. So what's the angle then? 50. What about V final? 32. I got to turn it a little bit. So basically, for an angle projectile that leaves the ground and returns to the ground, you're going to start with a certain triangle, and the exact same triangle will appear on the other side, but it's flipped because of that negative, that downward velocity. So that's pretty much the gist of this lesson. That when something leaves the ground at an angle, you break it up into pieces, and you'll get Vx, and you'll get Vy initial from that. It's also important to remember that this triangle is the same. So that's the gist.